Hey guys, welcome back to Next Fab Studios. This is Andrew again. Just want to show I did make the Tesla conference, and it was pretty amazing. I met some great people there. There's this project going on right now called Type 1 Roadshow, where it's going to be about a 3-month tour across the United States, ending in Mexico. That's going to be going community to community, setting up little permaculture guilds, and information about that with Tesla and how to make really efficient electronics that preserve the inertia of the electron. So that's going to be coming up. I advise to check it out. I'll send links in the descriptions down below. Right now, though, I came back to NextFab, and I'm going to professionally demonstrate the Joule Ringer circuitry. So here's the input. Our voltage is at 1.3 volts to our original battery, which we've been using this whole time. This is an amp. It's on DC amps. It's connecting from the negative of the battery over to the negative of the LED on the Joule Ringer circuit. This is set to AC volts, and this will be measuring the coming off the secondary winding, the voltage, which actually does not pick up DC. It actually only picks up AC volts. Here's our oscilloscope, where I'll be using a dual trigger. Channel 1, which is in yellow, will be going to the secondary winding, which is one winding of about 25 feet, 120 turns, of about 26 to 28 gauge wire. The channel 2, which is in blue, will be going to the base of the transistor, and then over to the collector or the emitter of the transistor. And that is connected to the Joule Ringer, which is a about 8-turn Bi-filar winding. It's about 18 gauge wire, and I don't know how many turns it is. So I'm going to be hooking that up sooner or later. I'm going to be showing you the charging effects, and I also am going to be hooking up these 5 LEDs and see what happens to our reading. They'll be hooked up to the secondary. So now I'm going to do the very famous wiring up with one hand, so bear with me real quick here. Alright, now it's hooked in. Light is on. So there our voltage. It is already going down. Milliamps, dropping pretty fast. Here's the first interesting part about the circuit. So here is AC voltage being measured on the secondary right here. I switch it to DC, and look, nothing. There is no reading on DC. Put it to millivolts, overload, so it's too high to read on there. Ohms, it's in, you never should be doing this on a voltmeter. But yeah, it doesn't read anything. So it's only on voltage, on the AC volt to read stuff. So that's 7 volts AC. Here's our reading up here, which is being a little weird right now. Bad connection or something. Let's see if I can smooth that out. Okay, so as we can see, this is already set to auto range. This is our primary. This is our secondary. Huge spikes going on the secondary right now. I'm going to bring that down a little bit. You can see how high up it goes. Like it's really up there. I can't even go all the way down. And that's set to 5 volt divisions. The primary right now is set to 500 millivolt divisions. So I'm going to bring that up a little bit. And you can see that it is basically right on top of primary and secondary in phase. I'm going to widen that out. There's the ringing on the secondary. Again, really nice ring where the primary, which is in blue, just kind of ends. See, the ringing happens up here. But on the secondary, it just happens all over the place. Very interesting effects. Looks very cool too. Maybe a cool art piece. So yeah, that's what's happening on there. Now I'm gonna hook up the 5 LEDs, and we'll see how that changes things. So here are my 5 LEDs. I'm gonna hook it up directly to here. Now you can watch the color of the LEDs change. Brighter, less bright over here. Watch this one and this one as well. So the left one's now brighter, which is on the primary. And now I'll hook up secondary, it gets dimmer. Lighter, dimmer. Now I'm going to show you what happens when I change them with the voltage. Voltage, not plugged in, hook up to secondary, the voltage goes up. Okay, let's see if we can get all 3 in the picture shot. So, on, voltage goes up, which just turned off. Voltage goes up, amperage goes up, the amperage goes down, sorry, and you get a lower AC voltage out. So not connecting, connecting, not connecting, connecting. So cool results. The more loads you put on, draws less off the primary, still get light out, and more voltage in the battery. So I'm just gonna, oh yeah, here's the reading. I'm not connected, connected. So you see it brings down that secondary voltage a lot. Also, it makes the duty cycle actually less duty cycle. So, not connected, connected, not connected, connected. So now I'm just going to leave it connected, and we're going to explore with the oscilloscope what is going on with the electron. So, with this load put on the secondary, we can see that you're getting this nice spike in the primary, and on the secondary you're getting the same thing, and the bigger spike happens on the outer end. We get this nice little oscillation happening. So all stuff that it's very cool to see happening, and it's very nice to actually have technology to actually record this. So that's what's happening with the Joule Ringer. This is not a full built Joule Ringer yet because I didn't have I messed up when I was finding this. Lightsaber asks to do 20 turns on the primary and 750 turns on the secondary, but it still lights, so that's cool. So that's the circuit. That's what's going on with efficiency, how many amps are going in and whatnot. And yeah, thanks for watching, guys. I'll be making another video shortly. Peace.